Now, process approach. We have a lot of history with the process approach. It goes back a long way, probably more than 100 years, from the time, I think it was Adam Smith who first described job specialization with pin making, and found that you could become much more productive if people specialized in their task. And gradually that grew up until I think it was Fred Taylor with his scientific management principles, which essentially were that somebody prescribes the procedure with which something is going to be done. And that then changed into time and motion with the belief that there was one best way to do things. That later changed in the 1940s and 1950s with the work of Edwards Deming, who argued that the outputs of an organization were not really under control of the person who was doing the work. There were so many other decisions that were made that they had no control over. And he argued that quality, for example, was a whole of organization concern. So there came this concentration on the processes of doing things as a way of organizing how you could tackle this problem. Now, ISO 9001 had a process approach. I think it was introduced in the 2000 edition of ISO 9001. I don't think it was there before, but certainly it was there in the 2000 edition. And so they had this process approach where they essentially said everything happens in a process, or everything is work outputs are produced using processes, and what your job of your quality management system is to determine what these processes are and the relationships between them. And now this comes down to understanding and managing interrelated processes as a system contributes to the organization's effectiveness and efficiency to achieve its intended results. And processes you can think of as the little box there with some sort of a process. It has inputs. It's got to transform those inputs into outputs or outcomes. It has controlling or controls that determine what they can do. It's things like management controls, budgets, how many resources you've got available. It has enabling mechanisms. Now, this might be the development environment, the processes themselves, and everything that went before, but things that enable the process to work. The elements of a single process, as this diagram is taken from ISO 9001, the latest edition, which I think is 2015, you have the activities of the process. These are the things that people actually do. Now, coming back from there are inputs that go into the activities, and they come from input sources. All right. Now, the activities are controlled in some fashion. As I say, there are time constraints or budgetary constraints. The organization policies on how things get done, that kind of thing. The process will produce some kind of outputs that will go to some kind of consumer of those, which may be another process or another part of the organization, or might even actually go to the final customer. But that's the general idea or the general depiction of a process. Now, in the software development world, there has been a fairly standard way of describing a process for software development, and it first arose or was implemented in the first attempt to describe the lifecycle processes of software development, which is in ISO 12207. Now, ISO 12207 was later, there was an attempt to say, well, in order to develop software, you have to know about more than just the software. You have to know about the system in which the software is fitting. So we have system development lifecycle processes, which is ISO 15288. Now, those two have been reconciled a bit, but the process descriptions are the same. and that is they have similar elements. So each process has a purpose. Why are you doing this? What is it going to produce? What's the whole point of this process? Now that is actually fairly central. What is the objective? Example is if you're doing software architecture, the objective is to produce a usable architecture. And there may be some more words around that to say, well, what is not only what you have to produce, but what it has to achieve. Now, the process outcomes, these are the observable indications that the process purpose has been achieved. So, to explain it a different way, if you walked into a room where somebody said this process has been performed successfully, what would you look for to prove that the process had been successfully done? Now, if it was an architecture, you'd see, or be able to see, an architecture. You would also probably be able to see the requirements that went into that architecture, the quality assurance checking that was done on it. That may be all. But these are the externally observable indications that the process has been done. The activities are what you do to produce those outcomes, and the practices are the specific things you do within those. Now, for example, the activities are the generalized professional practices that result in the outcomes. For example, if you're developing an architecture, you might write a conceptual architecture. Well, the specific practices, you could use UML, or you could use boxes and arrows, or you could do something else. Just different practices. You could evaluate the architecture, and there are different ways of evaluating the architecture. There are peer reviews. There are a couple of architecture evaluation methods. One is called ATAM, the Architecture Trade-off Analysis Method. There's another one, CBAM. I've forgotten exactly what that stands for, but there's also one that's called a HAZOP analysis, which is a very rigorous way of evaluating a design. Now, an example of a process, we'll take this one, the software architectural design. I've been talking about this a bit. The purpose of the software architectural design is to provide a design for the software that implements and can be verified against the requirements. Okay, so process outcomes. What are we going to look for to see whether this has been done or not? A successful implementation of the software architectural design process is an architectural design is developed baseline that describes the software items that will implement the requirements. Okay, so we have an architecture, and for some reason we are able to determine that it meets the requirements. Internal and external interfaces of each software item are defined. All right. And consistency and traceability are established between the software requirements and the software design. So there's got to be some form of traceability analysis sitting around the place that you can have a look at. Now, the activities describe the software architecture, transform the architecture requirements into a software architecture design that describe the top-level structures and identifies the major software items. Okay, so that is a high-level architecture design. Define the interfaces for the software items. Okay. You can do that in different ways. Analyze the architectural design. So analyze the architecture, evaluate it, or do something about that, and ensure consistency. This is your traceability. So this is the official process from ISO 12207 about what you do for a software architecture design. You may do something different. You may do something more or something less, but it'll be something of this nature. Now, the practices. Let's have a look at the practices for describing the software architecture. There are some possible practices. You can have a conceptual architecture. That's one way of describing the architecture. You could have an execution architecture, which you could portray with sequence diagrams or collaboration diagrams or state diagrams. Or indeed, what is very popular is basically a boxes and arrows diagram. You could have an implementation architecture. Now, define the interfaces. The interfaces are usually the message passing. So you could have a SOAP interface or REST interface, or you could have a parameter list that conforms to neither of those things. SOAP and REST are communication protocols. Whereas if you're simply passing parameters within the same process space, you probably would use a parameter list. Analyze the architecture design. You've got architecture trade-off analysis method, you've got software architecture analysis method, you've got a HAZOP analysis, and you have peer review. There are different ways you can analyze the software architecture design, and I won't argue that any one is better than the other. It's up to the organization to decide which ones they want to do. Ensure consistency. Usually this is some sort of trace between the implementation of the software architecture and its requirements.